Going to go ahead and transition to Dr. Mary Drewnoski. He's the beef systems specialist at the University of Nebraska Lincoln. Um, a really great resource and probably one of the unart well accepted as kind of a grazing residue expert in the field. And so we tasked her today with discussing a bit about determining stocking rates and also some agronomic impacts. And so with that, I'll turn it over to you.
All right, thanks, Beth. Beth's not biased at all. Just joking. So I'm going to talk about grazing corn residue, and I do want to just mention, as Beth said, we received funding from the Iowa Beef Industry Council for some of the research we've done. Some of this on impacts on cropland. We've also received funding from SARE. And then more recently from the USDA, which Beth's actually going to show you a little bit of the USDA data. So my job is to set the stage here for how do you determine stocking rate? And then Beth's going to tell you a little bit about why we might adjust that just a bit from the general rule of thumb we'd give in the high yielding fields. And then I'm also supposed to talk about the impacts on cropland, which is probably the number one question that I get, to be honest. So I play agronomist on TV, and today we're going to talk about the agronomic impacts. So the first question I'm going to answer is, how long can they graze? And that really depends on the yield in the field. So Connor kind of briefly mentioned that the amount of corn residue that you might expect will vary depending on the yield. And so we basically say that you can graze one cow for 1 month for every 100 bushels of corn grain that was harvested out of the field. And that's because the grain yield and the stover yield is tied together. It's not exactly a relationship that's 100% as the yields increase, the amount of stover per pound of grain actually decreases a bit, but it's a pretty good rule of thumb. And that is assuming that you're going to use 50% of the leaf and husk. And so Connor said, that by the end of grazing in that last study, they had removed 30% of the residue. And that's about right for 50% of the leaf and husk. The leaf and husk makes up about 40% of the total residue. But when we talk about target, we're really talking about what the cattle will consume. You're also going to lose some to trampling. You're going to lose some to wind loss and that type of thing. So we're being fairly conservative about how much we want to utilize, because honestly, there's a lot of residue out there that is really unsuitable to meet the needs of a cow. I mean, a lot of that is the stock, and the stock is very low quality. Okay, so if I say one cow for 1 month for every 100 bushels of corn, how do you then take that and say, okay, in this field, how long can I graze with this number of animals? So I'm going to give you an example. We have 160 acres. We have 250 bushel an acre corn, boy, I hope. And we have 150 cows. So how long can I graze? So the first thing that I would do is take my 250 bushel yield and divide it into 100 bushel units. And the reason I do that is, remember, we said one cow for 1 month for every 100 bushels. So that tells me how many cow months per acre I have. So in this case, 250 divided by 100, that's easy math, 2.5 cow months per acre. Then I'm going to blow that up by the number of acres that I have. In this case, 160 acres times that 2.5 cow months gives me 400 cow months total. Then I just divide it by my herd size. So in this case, my herd size is 150 cows, and that gives me 2.7 months. Or if you want to do it in days, you can just divide it by 30. So that's the easy way to get to, I know it seems like a lot of math, but it isn't that bad, to get you to an idea of how long they can graze. And to me, this is a good rule of thumb, and we're going to make adjustments because weather will make all of this change. This is probably what I would say is the maximum I would suggest, not the minimum. Okay, so why do we say that? Well, 40 pounds of residue is kind of the average amount of residue that we'd expect per bushel of corn grain produced, right? Corn grain is 56 pounds. So again, it's not quite 1 to 1, but there is a lot of residue per bushel that's being produced. And about 40% of that, or 16 pounds, is husk and leaf. As Connor mentioned, husk is the key because it's the most digestible component. It only makes up about 8 to 10% of the residue, with leaf making up about 30. And then we have cob and stem making up the rest. So somewhere around 60% of the residue. This stuff is not what we want to force them to eat. Like, we do want them to eat the candy out of it. We want them to eat mostly husk and leaf. And if we do that, then we can actually meet a dry cow's need without a lot of supplementation. You do need vitamins and minerals, and Beth's going to talk more about meeting cow needs, but this gives you an idea of kind of what our target is. So why is because we're trying to meet that cow's need, and over time they are selecting the best stuff first. So they're selecting mostly husk. So this is the energy content of the diet. That's IVDMD is just one way to look at it, would be energy. And as they're grazing in a field, the diet that they can select declines. So the energy content of that diet declines, but also the total amount of intake declines because they have to spend more time going and searching for the husk and the leaf material. So if we wait too long or we graze too far and try to use more of the leaf and husk, we run into a problem of the cow not getting enough into her body. So it's a combination of the diet quality is changing and her intake is changing. So what we want to do is we want to keep her eating leaf and husk. So if we do that, we can actually get by without providing supplemental protein to gestating cows. This was a study, it's a 5-year study down in southeast Nebraska. And what they did is they grazed at the recommended rate I just told you, 1 cow for a month for every 100 bushels. This was about 160 bushel an acre field. And they grazed for about 90 days. So at the beginning, the cows were in good condition, so they didn't need to gain, but we didn't want them to lose. And so they either didn't supplement them anything, or they supplemented them in terms of protein. They didn't supplement any protein or energy. That's what the control is, or con. On the supplement, they waited through the first 30 days, and then they started supplementing with 2 pounds of distillers per head per day. Now, they waited for the first 30 days because, as we kind of showed you just a minute ago, that energy content of the diet early on, because they select mostly husk and any downed corn grain, which isn't much anymore, right? But they select that first, and so their diet is higher quality earlier, and so we didn't provide any additional supplement then. But for the rest of the days, so for about 60 days, they did supplement. And if they provided some protein and an energy supplement in the form of distillers here, they gained a little more condition. The control maintained, the other ones gained. That's probably not unexpected. But we really didn't see any boost in pregnancy. We didn't see any boost in weaning weight of the calves. And in particular, I think the most important thing is whether or not it had an effect on the calf that was inside of that cow. So in range data, or when we're feeding low quality forage like straw, which is probably somewhere around 45 TDN versus, as we talking about with husk, we're somewhere around 60 to actually even 70 sometimes TDN, and leaf, which is usually around 48 to 55 TDN. So higher quality. We talk about corn residue as being low quality, but it's actually quite good in terms of energy content. It's quite low in terms of protein content. But in other situations where it's lower quality forage, and so it's both lower in digestibility or energy and lower in protein, we see a fetal programming effect. If we provide some supplemental protein, we actually see the performance of the calf once it's born is better. And so, there's always that concern. Are you giving that cow enough to where her offspring is going to perform well? So we actually looked at that by looking at these heifer progeny. So we kept the heifers out of the cows that were either supplemented or not supplemented over this 5-year period, and basically looked at how they developed as a heifer. And we saw no difference in their average daily gain post-weaning, no difference in their age of puberty, and no difference in their ability to get pregnant. So the bottom line is that if we graze properly, that the corn residue can actually meet the needs of a gestating cow. Now, when we talk about lactating cows, all bets are off, and Beth will talk more about that. And of course, like developing heifers, anything with a higher requirement, we do need to start supplementing protein and even energy, but we can get it by quite well with just some mineral and vitamins on our gestating cows. So how do we make sure that we are meeting needs? And as Connor alluded to, monitoring husk is a great way to do that. When we are having a harder time finding husk, it's probably time to start wrapping up grazing. And so in some situations, that might be before the recommended rate would suggest. And that's because one of the big things is how much husk loss do you have to wind. So depending on your road direction, your stock height, you may have a lot of husk that ends up outside of the field for you to graze. And so you also have the challenge of particularly warm and wet winters where they might trample in a lot of the forage. So going out and monitoring is probably the best thing you can do. You can kind of get an estimate based off of the rule of thumb, but really there's no substitute for going out and looking at what the cattle have access to, and husk is the key. This is actually a picture. There's a line down the middle here of a fence, and there's ungrazed that is on the left, and then there's grazed to the recommended rate that is on the right. And it's really hard to see a huge difference, right? There's a little bit of bare ground on the grazed. It's 20 to 30% of the residue is removed if we look at residue cover, like ground cover. And so the big difference is if you start looking for husk. So I've kind of highlighted some of the husk that is hiding in this residue, and I could find one in the grazed, and I could find here, I had 5 in this picture of the ungrazed. And that's the key difference. It's all about the husk. So current recommendations is if you allow them to be selective grazers, you don't need to provide protein or energy supplement to spring calving cows. If you go beyond the recommended rate, or you have a lot of trampling loss or wind loss, you may need to start supplementing protein and energy. But all assumes that proper utilization. And weather is going to be the big factor. And so I'm going to talk more about this particular picture on the left here, where I have, this is actually a trial that we conducted where we actually grazed in the spring to try to kind of create the worst case scenario in terms of cattle compaction. And I think we did an awesome job at creating something that most people would cringe at. There's a lot of surface roughness. There's a lot of pugging here. They basically made most of the residue be integrated into the soil because we waited until it rained and then put out a bunch of cattle. And our goal was really to cause as much damage as possible if they're going to cause damage. But I also want to point out wind is a huge thing, and so it varies from field to field. And this right here is some amazing could consume if it was inside of the field, but when it's on the other side of this fence, it doesn't do them much good. Okay, so let's talk about the impacts of grazing corn residue. So I kind of set the base of what we typically are trying to target, which is 20 to 30% of the residue being removed, mostly leaf and husk. There's still quite a bit of ground cover out there. That's kind of the goal. And to me, that's kind of the gold standard of what we're trying to achieve. We have a study, it's actually still going, it's almost at 30 years. I'm going to have to sample it again. But we have a study where in Mead, which I kind of have on the star here, it's a silt clay loam. And we, for 16 years, grazed corn residue and evaluated the impact of grazing that corn residue. And one of the big questions we were trying to ask is do cattle cause compaction when grazing corn residue? And there's kind of two measures that you might think of when you think about compaction. The true measure of compaction is bulk density. And so that's basically measuring the porosity of the soil. So it's really about how much airspace is in between soil particles. And that really is the best measure. And then you have penetration resistance. Penetration resistance is probably what most people actually would be able to associate with, because it's actually the pressure needed to penetrate the soil. And so when you go out with a planter, it's the amount of downforce it takes to get the seed at the depth you're looking for. And so when we talk about compaction, I think a lot of people think about penetration resistance, and it is a decent simulation of root penetration and how much force it takes for those plants to actually have their roots go through the soil. But it's a key thing to understand that it's affected by soil moisture. And so if you have a piece of ground that's drier versus a piece of ground that's wetter, the drier ground will always have an increase in penetration resistance. So it's much more variable across time. And it's not really a good long-term measure, if that makes sense, because of how much it varies just by soil moisture. So what I have here is I have two graphs. One is of the bulk density, and that's on the left, and the other is on the penetration resistance on the right. And then I have the various depths at which we sampled. So we sampled from 0 to 2 inches, 2 to 4, 4 to 6, and then 6 to 8 inches, and looked at the porosity of the soil. So as you go on one of these graphs from left to right, the soil is getting more compacted or more dense at each of these depths. Then I also have basically the triangle, the open triangle, that's the fall grazing treatment. We grazed for 45 to 60 days to our recommended rates. We have a spring grazing, which we delayed the start of grazing, and we actually waited until spring to start grazing. And we actually had a bit of higher stocking density, but again, grazed to the recommended rate, or we had a control where we didn't graze. And on bulk density, after this 16-year period, we saw no difference between the fall grazing and the control at any of the depths. And actually, we also, even though you can see there's a shift, statistically, there's no impact of spring grazing compared to the control on bulk density. And the other thing that's really important to recognize is that, and we think about bulk density and we think about where we might actually start seeing an impact on yield, we're bumping up against it at that 2 to 4 inch depth. But again, we're not really over that where we would actually expect to start seeing impacts on yields. If we look at the penetration resistance, here's where we do see a significant shift in the spring grazing treatment, where we do see that it takes more force to get through the soil, basically at all the depths compared to the control, but we saw no impact of fall grazing. However, I want to point out, again, we are still below the threshold where we expect an impact on root growth. So even though we do see this shift, and if you were trying to plant, you would have to have more down pressure in that spring graze treatment to actually get your seed at the same depth as in the other two treatments, we still were below where we'd expect a negative impact. And indeed, when we look at yields, now I'm only showing the no-till data. We actually, for the first 10 years, had other treatments where we had a spring tillage treatment and a ridge till treatment, which we got rid of in the later years. But we saw the same things regardless of tillage method. So I'm showing you the long-term no-till data. And that is that if we look at the subsequent soybean yield, we actually see an increase in soybean yield with the fall grazing compared to not grazing. Now, remember, this is high yielding field, right? It's 200 bushel on average. And so we were seeing actually a positive impact of fall grazing and a tendency even for spring grazing to have a positive impact on soybean yield. Now, this was in a corn soybean rotation. So we also monitored the corn yields. And we see kind of a similar trend where we actually might see positive impacts of grazing on yields, although it's only a tendency here at the fall grazing compared to the no grazed for there to be an improvement in yield. So definitely no negative effects. If anything, we're seeing positive effects of grazing in this high yielding no-till situation. But as I said, we were still seeing the same thing even in spring tilled systems, which was kind of interesting. But why? So why would grazing have a positive impact? Well, one of the things that we saw, which was really kind of cool, was that we actually saw an increase in the soil microbial community. So the total microbes in the soil increased with grazing compared to not grazing. And in particular, the two types of microbes that were of interest in my mind anyways was the actinomycete bacteria and the saprophytic fungi. Both of those microbes actually degrade kind of cellulosic and hard to degrade material. So think corn stalks, think corn residue. So we increased that population, which means we probably improved the nutrient cycling, both through the cattle themselves and through the microbes in the soil. And we may have allowed some of the nutrients to become more available earlier in the season, especially for those soybeans after the corn. And that's why we might be seeing that improvement in the yields with grazing. Looking at the organic matter, grazing in this long-term study, we didn't see any negative impacts. Again, if anything, the trend is maybe a positive trend with fall and spring grazing. Statistically, it wasn't different. That's why we've continued to study just to see, okay, in a long-term situation, will we see this pop out? But no negative impacts with grazing on the soil organic matter. And we looked at soil fertility after this long-term of grazing, and we really saw no effects on the nitrate nitrogen, the available phosphorus, or the exchangeable potassium, which really is kind of what I would have expected, because if I think about the nutrients that a cow retains, it's very little in terms of nitrogen, phosphorus, and potassium. In fact, the residue itself doesn't have enough phosphorus in it to meet her needs, so you actually need to supplement. So you should be importing phosphorus. Now, admittedly, depending on how you're grazing and where the cattle are loafing, they may change the distribution of nutrients. And that might be one of the positives, like to doing something like strip grazing. There's not a lot of data that suggests that we see huge benefits to the animal, but from a nutrient distribution standpoint, we do get better distribution of that urine and that manure with the strip grazing situation. So we decided to take it a little further. Okay, so we had 16 years of this study, and we still kept getting questions, especially actually from our farm manager. So one of the things that we do at Mead is that we put a lot of calves out on stocks in the winter, like 400 head in a group, and they go out and they graze, and we move them around. And as we get closer to spring, we start bringing them onto the facility, and we start congregating them more and more onto fewer and fewer acres as we get later and later, because they're trying to plant and all those things. Well, his concern was with that later spring grazing and those high stocking densities, were we causing compaction? Because he said, indeed, I have to have an increase in my down pressure to be able to plant. And so we decided to just go whole hog and create like the worst case scenario. So we did a 2-year study where we compared not grazing. So we had this land from this long-term study that we continued to not graze. And then we had 2 treatments. One treatment was a normal stocking density. We grazed for 45 days. We started in mid-February, and so we grazed through mid to late March. And then what we did to have the same number of head days per acre, but over a shorter period of time with more head, we basically grazed for 15 days and stocked at 3 times the rate. So the goal was same number of head days. So theoretically, you should have the same residue utilization. But we also waited until March, and then we waited until we got a big rain, and then we set them out. So we were trying to have like, this is like everything we tell you not to do, we're going to do it. Again, this was mostly on a silt clay loam, but there was also some silt loam soil on this field. So this is what the treatments looked like after we grazed. So this is the no graze treatment, and you can see the stalks are still standing up. There's a little bit of bare ground here and there, but you know, kind of what you'd expect. This is what the normal stocking density looked like. You know, some of the stalks have been knocked down, and that means you're probably going to get a little more wind loss. And then this is the high stocking density. So remember, same head days per acre. The biggest difference is the stocking density and the fact that we had a whole bunch of head in the period of time when it was wet and thawed. Now, the normal stocking density also grazed during that same period of time. So this is no slouch in terms of what you might be thinking about for spring grazing, but this is like the worst case. The high stocking density is really that worst case. So what did we see in terms of compaction? Well, we did see an increase in the bulk density with grazing, regardless of whether it was a normal stocking density or high stocking density. There really wasn't a difference between those two, but relative to not grazing, there was a slight increase. But again, that red line there is the line where we might expect some impacts on the crops. So yes, we can pick it up, but does it matter? Probably not, right? Then we talk about penetration resistance. And again, we do see a rather large increase in this case due to grazing, but again, below the threshold where we'd start expecting a negative impact on the crop growth. I also want to point out, you know, you see that big increase in penetration resistance. Here's one of the things that you have to keep in mind. We did significantly reduce the residue cover in both the normal stocking density and the high stocking density. So because there was less residue cover, there was a little bit less moisture in the soil, and that tends to make your penetration resistance creep up. So yeah, if you go out to plant and you compared the non-grazed to the grazed, you'd have to have more down pressure on the planter. We also, and probably more of a problem, in my opinion, it was the surface roughness. So the normal stocking density did increase surface roughness. So what we do to measure surface roughness is essentially we take a chain that has a known length and we lay it down. So now it's going across all the bumps and dips in the soil, and we actually measure its length and we look at how much it changed. So the more changed, the more rough the soil is. And so indeed, in the high stocking density in particular, we had a lot of change in the chain length. We had more surface roughness. And even in the normal stocking density, we had more surface roughness than in the no grazed. That's probably common sense. You could go out and look at it and say, yeah, it's pretty rough. Which means you did have to slow down with the planter to achieve the goal of getting the seed into the ground. And we did have to put a little bit more down pressure, especially in the high stocking density, to get the seed into the ground. So that's a negative, and I don't want to overlook that. But we did not negatively impact the soybean yield. In fact, we saw a benefit again to grazing. Now, I want to point out, like, this is not me suggesting that you should go and do this, especially the high stocking density in the spring. But it does tell you that, let's say, you know, you mess up, like you have the cattle out there, you can't go and get them off in the spring on time. You get a little bit warmer weather than you normally would. You get a rain event, and hey, you know, your field looks like ours did. The long-term effect is basically nil. What it will do is it will change your planting. It will make the crop producer mad because, you know, you're gonna have to slow down on the planter, and the ride is a little rougher. So it's not without its downfalls, but the fact is that the amount of compaction, even in this scenario, is basically negligible, and it doesn't build from year to year, which is the other interesting thing. So even in the long-term situation, we're not seeing an increase in bulk density or penetration resistance, especially penetration resistance that's consistent. We've done other studies across the state. This is some on-farm studies in continuous corn systems as well as corn soybean systems. Some were irrigated, one was not. Most of them are no-till, but we've done strip till and even like spring tillage. And really all of them kind of show us something similar in terms of the results to the other studies that I've showed you so far. So this is penetration resistance across all of those sites. And there's kind of two things I wanted to point out. One of which is there's no consistency of the impact of grazing on penetration resistance, and especially if you look year to year. So let's look at the middle one, Norfolk in 2015. This is corn on corn. So this is the same piece of land from 2015 to 2016. And if you look at the control compared to the grazed, there was an increase in penetration resistance in 2015. If you go over in 2016, it is not elevated compared to the control. So again, you really don't see this consistent carryover effect, even though in 2016 they grazed again. And so, you know, this is something that's important to recognize, that probably penetration resistance is one of those things that makes you think, you know, your observation is that there is this compaction, but really bulk density is probably the best measure of whether or not you're having compaction. Over the 3 years at all of those sites, we didn't see any impacts on corn or soybean yields. And in fact, we're kind of seeing that similar trend of maybe even some improvement due to grazing in terms of the corn yields, especially in the continuous corn systems. And so I think that's important to recognize, is that across locations, we're seeing kind of the same things over and over, that grazing of corn residue really doesn't have significant negative impacts on the soil. In fact, you can see some improvements in the soil microbial biomass, which is a positive thing. We're not seeing like nutrients being removed. And so there's minimal compaction even when we're grazing in the spring. Now, admittedly, if you graze in the spring, you have a risk of increased surface roughness, and you may need to increase the down pressure that you need to plant. And so this is one of the important things. Like if you're going from one field to another and it's a grazed versus an ungrazed field, you probably do need to go out and check and make sure that you're getting the seed at the depth you want it, if that makes sense, because there can be some differences in that penetration resistance, depending, of course, on the moisture content of the soil. We see minor improvements in the subsequent crop yields or no effect. We do see this increase in the microbial biomass, which can be a real positive thing, especially in no-till systems and high-yielding fields. The other thing that I haven't mentioned, because we didn't actually do measures, but volunteer corn is another thing that cattle are really good for helping out with. So if you do happen to have some downed corn, cattle can be your friend there. And then we really saw no effect on the nutrient content of the soil. So in general, I would say that in terms of the impacts of grazing corn residue, there's a lot of positives, especially in well-managed situations. I think fall grazing really is very low risk in terms of negative impacts. And even spring grazing is doable. Don't don't do the high stocking density in the wettest part of the spring. But you know, the cattle compaction, I think, is it's more of a perception than a reality. So with that, I will open it up to questions about grazing corn residue impacts